So in this video you can see, if you imagine that that flat board is now a ceiling and not a wall mount. So this camera is now, instead of being mounted on the wall as it is really, but imagine it's now mounted, that this becomes a ceiling. This is the way we would have to change that mount. We would simply have taken out one piece, this piece here, out of this, which had turned it sideways. And so we have our mounting piece, this piece, and then now the sliding pieces, which allow us to slide and adjust everything so that if it was hanging down below the camera now, if this was looking at it from the side, it would come up from underneath and drop down perfectly. So that's the changes. So with the same parts, we can now handle a wall mount eyeball camera or a ceiling mount eyeball camera with the same bracket, just by removing one part. So we need these two slides at those lengths that we discussed, changed, modified. These parts are perfect, that part is perfect, and then we'd need just extend those slots out further and make sure that these still fit into the same ability to have them move and turn, but now slide also. Really gives it a lot of adjustment ability now to make it line up, because just a little bit of adjustment on, well, that's how tight those can be tightened. It makes them hard to adjust. So that's good. We like that. It makes them really difficult to move. So once this is changed, this is the weak link right now. I cannot tighten these down or it just crushes right through the hollow rails. And once that's solid and narrower, this screw should just bite and create a nice lock. The other thing that we might consider, Carl, is when we make this solid, is putting a groove indentation all the way down this side, on each side of the slot, so that when a standard hex head would be placed there properly, it would actually slide in that secondary slot. And I can see you could only need to put it on one side, because we can flip this over. And the benefit of that slot, let's say that that slot was about, it would be the width of, from flat, that was magnetized, from flat side of the head nut to the other flat side of the nut, all the way down and around. The benefit of that would be that when you're tightening it, you wouldn't need a wrench on the other side, but that slot would hold the nut and keep it from spinning. So you have the narrow slot all the way through this, that the screw portion would fit through, so about the same width as a screw. And then you'd have a secondary slot indentation more that would be maybe, I'm not sure how deep it would have to be to keep this from spinning, maybe a 1/16 of an inch. We have to be careful to allow it to still spin, or allow it to not spin, but at the same time not weaken the part. So we might have to do a little testing with that, but I'd say a 1/16 of an inch indentation, that's the width of the nut head, all the way down on just one side of this would be appropriate. So hopefully that makes sense for the reasoning and the purpose, and this is what we get with it. It comes out, goes down, can be adjusted, and this really works well with the least number of parts. I'm liking this bracket. Neat design here, but you know, once again, we made ourselves make it more complicated than it needs to be. This is kind of limiting. This allows us to take one of these out, add extra ones if we need it. Kind of a universal part where we keep these. We could have 3 of these per package and only use 2 or whatever. But I think that's going to be the solution we're looking for. I will get this queued up and sent to you right away. Thanks. Bye.